This is a branded podcast from Latitude Studios.
In the late 1990s, in the middle of the dot-com boom, Tristan Doherty thought he wanted to be a computer engineer.
I got about halfway through my undergrad and I decided I did not want to make little black boxes with blinky lights on them. I thought that was probably not very exciting. So I moved into mechanical engineering and I wanted to make robotics. I wanted to do stuff where I took control systems and impacted the real physical world.
Tristan pursued projects that were far more interesting than boxes with blinky lights. He was on a university team that designed a Formula-style race car. He designed interactive art that integrated technology. And at the end of school, he faced a question that lots of people grapple with.
And I sort of had to make a decision at the end of that. And I said, well, what's my true calling? Where am I being pulled? And at that point, I was being pulled back into car racing.
Tristan went all in on racing. He started as a data acquisition engineer who analyzed tens of thousands of data points coming from a race. And he eventually became a race engineer for an IndyCar team who called the shots on the setup of the car.
Ultimately, it's me on the radio that's saying pit, pit, pit. And a lot of stress, a lot of pressure, but very rewarding.
Car racing is a very high-stakes sport. It requires a team of engineers like Tristan to analyze data and make real-time decisions about how to operate the car. And as he told Stephen Lacey, one small mistake can be catastrophic.
So it was really sort of a fascinating culmination of a lot of different areas that came together. In racing, you have this huge, obviously, technology piece of it. You have a big sports piece of it. You have a logistics piece where you have to make it to race day. And layered on top of that is the sort of psychology aspect of dealing with the driver and dealing with the teams.
Were there any harrowing moments? What kind of problems were you having to overcome?
Oh, there's a lot of problems in racing. There's a lot of chaos. I remember vividly once in Australia, we were doing the morning warm-up on Sunday morning. It was sort of a 9 a.m. warm-up or something for an 11 a.m. race. And these are usually really low stress. You just go out, you do a couple laps, make sure everything's okay. And we come back from the warm-up and the engine had failed and the engine needed to be replaced. And it was an impressive orchestra of chaos that brought the entire team together. Everyone from the team owner down to the new mechanic who just joined a couple weeks before that was just madly trying to get this engine fixed. And everyone's just sort of gathering parts, what's needed here and there, and just trying to really, single-mindedly, that one mission that the entire team was 100% focused on. It's a little cliched maybe to bring that back to sort of climate and back to the energy transition, but I think that a lot of people in the industry have that similar sort of really sort of single-minded goal of what we had to have ahead of us and what we really need to accomplish.
Today, Tristan is the Chief Product Officer at LG Energy Solution Vertech, the vertically integrated U.S. storage arm of LG Energy Solution. The company executes large-scale storage projects, from cell manufacturing through system integration, O&M, and warranties.
We have to really deeply understand the technology and we have to understand the business. And hopefully, when we've solved everyone's problems, we find success.
And Tristan, who's no stranger to things going wrong from his racing days, is also focused on improving the safety of battery storage plants.
Now let's get to developing news out of Monterey County. A fire burning at one of the world's largest lithium battery storage facilities, and it continues to burn more than 24 hours after it started.
Earlier this year, the Moss Landing battery plant operated by Vistra Energy caught on fire, engulfing the LG batteries inside the building. LG Energy Solutions provided the racks and batteries for this project, while other providers worked on the balance of systems. In the wake of the fire, Stephen Lacey sat down with Tristan to explore what has changed in the industry in the months afterward.
It certainly was a huge wake-up call for the industry, a very pivotal, I think, moment for battery safety, but one that I think is going to drive us forward and really drive, I think, some positive changes that I'm looking forward to in the future.
In this interview, Stephen and Tristan outline design changes, why vertical integration is so critical for improving safety and performance, and explore the future of U.S. supply chains.
So it seems appropriate, since we have a former race engineer with us who has dealt with many challenges, to start this conversation off by talking about safety. The Moss Landing battery fire in California that recently happened was a pretty pivotal moment for energy storage. And I wonder if you can talk us through what happened and what we learned from that incident, and how is it shaping the industry's approach to safety?
I think, as is always the case with these huge fires, there's some things we know. There's a lot we don't know yet. And there's probably plenty that we may never know. Fundamentally, though, and I think we don't yet know what the root cause is. We're working really, really closely with the site owner and all the local authorities to try and figure it out. What we do know is that mid-afternoon, January 16th, one of those modules went into thermal runaway. What we don't know yet is we don't have an official sort of answer on is for some reason that water system didn't work correctly. And that thermal runaway spread from one module to the next and eventually to an entire section of that building, ultimately destroying it. And so just a little bit of background about that site, because it was an important site, I think, in the history of energy storage and energy storage deployments. It was the largest site by a long shot for many years. But it was a retrofitted gas and oil power plant that was originally built in the 50s. And in 2013, California had passed a law that was sort of requiring a big build out of energy storage. And Vistra, the project owner, answered that call in 2018, announcing that they were going to build this Moss Landing project. What they did was they essentially pulled all the equipment out of a massive turbine hall and they replaced it all with battery racks. The incident earlier this year was in that first phase of the Moss Landing complex. There's a couple other battery projects on that complex, but they weren't involved in this particular incident. I think that it's really worth noting that there was a certain era in the energy storage industry where anything over a certain size, any project over a certain size, and people listening to this may laugh when they say that certain size maybe was 20 or 30 megawatt hours, which seems teeny tiny compared to today's standards. But anything that was of any meaningful size would typically go into a building. And that was just sort of the design practice of the time. Things have moved on quite a bit since then, but that was the case. And so these systems, they were racks essentially sitting in a building. They had a water-based fire safety system that was essentially when a thermal runaway was detected, it would spray water on the module to reduce the heat in that module and to make sure that thermal runaway didn't propagate to the modules around it. And that's sort of the layout of this site. I think one thing that's really worth noting is that these huge projects, that there's a lot of different players on site. This was also a time in the industry when LG wasn't vertically integrated as it is today. And then there was sort of layers and layers and layers of other players at this project site that all had to come together and everything had to work together for it all to function. What I'm really thankful for, and I think everyone is really thankful for, is that all the first responders did an amazing job and nobody was hurt. Thankfully, all the environmental measurements that came back, all of the EPA has been doing extensive testing all around the site. All those measurements have come back within sort of safe limits. And I hope that in the next months, we're going to have a nice extensive report that will help the entire industry learn from this event.
And are you seeing a shift to more containerized battery storage solutions compared to like a building-based installation like Moss Landing? How is that evolving and how does that impact safety?
So definitely there has been a huge shift to containerized systems instead of building-based systems. You see almost no building-based systems built now anymore. Everything is essentially containerized. There are a lot of different reasons for that. Economic is one big one, but I think safety is another aspect that's an important piece to talk about. Fundamentally, I find the easiest way to think about why containers help on the safety front is that you're just splitting the problem into smaller pieces. A container has a limited amount of energy in it. It has its own fire safety systems in it, and it has walls and potentially even air gaps around it. So when one container or when one module in a container has a failure, goes into thermal runaway, ideally that module is dealt with by the fire safety system. Maybe, hopefully, that module just turns into a non-event. That module's failed, you pull it out, you replace it with a new one. What you think about in terms of safety, you think about worst case scenarios. And now the worst case scenario is simply that you lose a container. Maybe the next container over gets a couple scorch marks on it, but typically right now, the worst case scenario is you lose one container, which is several orders of magnitude less than what we saw at Moss Landing. And so, fundamentally, it's just what's your problem? Make it a smaller problem, and then when that problem happens, it's much more manageable.
So looking ahead, are there other safety innovations or design approaches that you're also excited about that can improve safety?
That's a great question. I see there's a lot of innovation happening right now at a lot of different levels. There's plenty of cell level innovation that's happening. There's a lot of chemistry work and a lot of cell safety work that's happening. But I also see a huge amount of effort and a lot of progress being made at the system level. From a safety innovation perspective and from a design approach perspective, I really think that it's a multi-tiered approach. We're continuing to see a lot of sort of system level safety improvements that are happening. They're happening along with the cell level improvements. I see a huge play in terms of software. There's a big component to software and all the algorithms and AI and machine learning that are really being able to identify and catch failures before they turn into bigger failures. And so there's a lot of advancements here in terms of how much data is being collected and how you relate that to the things you know about the cells. And honestly, that's one of the big advantages that as a vertically integrated play that we have, because we have the sort of entire life cycle of data that goes along with every cell. But over top of it all, I think there's a big piece in terms of quality. And I talk about quality not only at the sort of cell level and the manufacturing level, but also at the system level, and how these projects are coming together. And I think that there are a lot of sort of top tier integrators that have done a really great job of quality at the project level, but there's also this layer of codes and standards, which I think is something that you think at the industry level that's going to force and require every single project that gets deployed to really meet that high bar of safety and system effectiveness. I want to sort of go back though a little bit and take note of how far we've come. And I think there's an EPRI report out there that I think a lot of people in the industry have probably read and seen. But if you look at the number of failures and the failure rate from 2018 to 2023, it was just a 5-year span, that it dropped by 97%. And I think that's something that's really incredible and something to be really proud of. Obviously, we still have a long ways to go and there's still a lot of work ahead of us. But the knowledge that we made that much progress in that short a time period, I think gives me a lot of confidence that these advancements are coming and that we'll get where we need to get.
Let's turn our attention to manufacturing now. I know LGES has made some pretty big investments in U.S. manufacturing. Can you talk about what those investments entail and what's the strategic approach to the American market?
We've made a lot of very big investments. Right now, we've been working heavily on localizing our production into the U.S. We've been doing that for a long time. Just for a little context, we started construction on our first factory in the U.S. in Holland, Michigan. That was back in 2010, so that's almost 15 years ago that we've been working on this. We had cells coming off that line in 2012, and that was back in that was for the EV market. But we've continued to build from there. So right now, we've got 7 battery plants in the U.S. that are either producing or in construction. We've got also an advanced sort of cathode facility. And the one in there that I care the most about being on the energy storage side is our Holland, Michigan. It's the second Holland, Michigan plant that's producing 16.5 gigawatt hours a year of energy storage dedicated cells. So that's sort of our side of the investment. We've had this, for many years, we've had a strong strategy of diversifying away from China. And so we sort of have a 2-step strategy to localize into the States. Step 1 is to find a supplier that is outside of China so that we have more of a global supply chain. And then step 2 is to bring that supply chain into the US. And that takes a long time. And I think that's something that is sometimes lost. It seems really easy. Just flip a switch and we'll just build this stuff in the States. But it takes years to build local supply chains, to qualify local supply chains, to get the right people and the right skill sets locally to be able to build what are ultimately really high-tech products. But I think so far we've been quite successful and we're in a good spot. Right now, coming off of the Holland, Michigan line, we're on schedule for early next year to be 100% non-Chinese in terms of all of the components and subcomponents that are going into those ESS cells. So it's a huge testament to the work, and it's a lot of work that's gone into it by both the US and the Korean teams to make all of that happen.
So this has been a long-term strategy to invest in the U.S. and diversify your supply chains. Of course, this became a lot more urgent coming out of the supply chain disruptions from COVID, and now we have these new challenges related to tariffs. How is the current trade environment impacting project timelines and your investment decisions?
It's taking a lot of analysis and reanalysis and reanalysis every time something changes. I think there's a lot of uncertainty right now in the environment, and we've been lucky that we can be very flexible, but it's also been a huge strain on, I think, us and everyone in the organization and everyone in the supply chain and everyone in the industry. We have to remember that these are enormous investments. LG's got sort of $25 billion investing in the U.S. supply chains, $1.4 billion on that ESS factory. That's not something you just turn on and off at a moment's notice. You have to have a little bit of certainty. You have to know that it's going to make sense from a business perspective to be able to put down that kind of money. And we're lucky that we're a large multinational company with a balance sheet that can weather some of this uncertainty, but it's not unlimited. And what I do worry is I worry that there's a lot of other players in the supply chain, in the broader supply chain, that don't have those kinds of balance sheets and maybe can't afford to have that kind of patience. And we're seeing projects that are being paused, that are being delayed. We're seeing suppliers that are rethinking their strategy and what makes sense and what doesn't make sense. It's the goalposts are continually shifting. And when that happens, you don't really know what to do. And so you're sort of paralyzed. So what I really fundamentally worry about, I think, for the industry is not that we're not going to keep moving forward. I really do fundamentally believe that the economics are there for this industry. And I think that the ultimate goal is something that we will achieve. It's just a matter of when and how fast. And this uncertainty, I think all it does is it just slows that down. If you don't give people a clear signal, they're not going to know what to do and they're not going to react in the most effective way possible. And people are going to kind of make, I call it a millimeter of progress in a million directions, right? Which isn't an effective way when you're wanting to get single-mindedly to an end goal.
I want to get your thoughts on integration strategies. So there has been a significant evolution in the size and type and integration strategies for storage, from building batteries and connecting them to the grid to designing power plants that happen to use batteries. How is this change driving system integration and project development?
I think that there's been a strong shift in the mentality of how you integrate these plants, and being a part of a company that has control over the supply chain from the cell all the way out to your transformer or even your interconnection allows us to think differently. We've kind of been able to flip the script on how exactly to do these projects. Originally, I think if you run the clock back into the sort of early 2010s, a lot of people would say, hey, I have all these batteries. I've got maybe some EV batteries. What can I do with them? Oh, well, let's put them together in a rack. Let's put those racks together in a container. Let's put those containers together in a project. It was very, very inside out. It was starting at the cell, and then it was sort of multiplying and building and to create your project. Whereas I think the mentality has taken a strong shift. And now we're thinking from the outside in. We're saying, what does a power plant look like? What value does it need to bring to the grid? What does it need to do to be really effective and, to meet the business goals of the operator? And what do the batteries need to do that are going to do that? And so you start at the power plant, and then you move into your power block or your enclosure, and then you move there into your module, and you move from there into your cell. And so the direction of design decisions and the direction of design intent has kind of flipped 180 degrees, which is a fascinating change to see in the industry, but it's also one that I think is creating much more effective and much more powerful designs.
And what are the advantages of vertical integration?
Well, it's the ability to do exactly what I just mentioned is when you're a system integrator and you're using a third-party cell, you're often kind of stuck with what your cell suppliers have. You've got to look through a catalog, figure out what's out there, how you put it all together to meet the need. When you're fully vertically integrated and you are understanding what the customer is truly needing, and you can take that information and pick up the phone and talk to the designers who are actually designing the modules and the cells and describe to them what challenges you're facing. And they understand that they can make their designs work much, much better with the overall plan. And I think that's really a strong key. I see another big strength of vertical integration in just understanding and being able to control the supply chain and being able to manage the supply chain. One of our advantages and one of our superpowers as a battery company, and being the sort of largest non-Chinese battery company out there, is that we have not only ESS production, but we also have EV production. And this was one of the plays when we decided to shift our original plans of building the ESS production facility in Arizona and shift that to Holland, Michigan. It was so that we could build more cells and build them sooner. And that was only because we had the experience in the EV plants, and we had this EV plant, and we had these facilities that we saw market shifting. We saw that the EV market wasn't growing quite as fast as the ESS market was, that our forecasts were sort of not quite right, but we could readjust. We had that ability to be flexible, and we had that ability to readjust. And then instead of taking 3 or 4 years to build a complete greenfield battery factory in Arizona, we could take 6 to 12 months, take an existing shell, an existing building that had all the permitting done and had all the infrastructure and all the utilities, take all that equipment that was originally destined for Arizona, send it to Michigan, and we were suddenly up and running almost a year earlier with ultimately a higher level of production per year. So that vertical integration, that ability to sort of maneuver things around and change and adjust to the market environments and the conditions really gives you the ability to I think, be more flexible and to be more adaptable in what is ultimately a really sort of variable environment right now. And so the players that have that adaptability and have that power are in a good spot, I think, right now.
And tell me about how the software is evolving. As the use cases for storage on the grid diversify, what is happening in the software side as part of that stack? How are you approaching software development? What's changing that's most interesting?
Yeah, software is an interesting piece. I think there's a lot of really interesting technology that's happening on the software side. There's a lot of AI machine learning we mentioned earlier in terms of the safety aspect. There's a lot of operational efficiency and keeping really high availability of your systems. We're also working a lot with how to operate energy storage more effectively on the grid. What's the optimal dispatch? What's the way to play in the power markets and really be effective there? I think the other side of software, and it flows into availability and safety, is the cybersecurity piece and the domestic supply chain piece. And so I see software as a really key component of our supply chain. The fact that we build all of our software either in the US or in Korea, the fact that we have 100% visibility over every piece of every single controller in our enclosure, I think puts us in a stronger stance, I think, from a safety and cybersecurity perspective. I'm happy to see that we've brought all that in, that's actually one of the really strong components that we bring to market. And it just fundamentally, I think, makes for a better product. It's more secure, it's more stable, and ultimately it's going to bring better value to the customer.
It's impossible to have this conversation without talking about the demand backdrop now that is making storage even more valuable. And of course, around the world, but particularly here in the US, we're seeing this surge in demand, particularly due to data centers. Of course, it's a wide variety of things like electrification, factory development, and data centers. And I'm curious about how you see this shaping the market for storage. Is it changing the need for storage, the applications for storage? How do you see this demand backdrop influencing deployment?
Well, there's a lot. It's a very foundational shift in the energy markets and the energy space. Everyone, I think most people know, or has been talked about at quite a bit in the last sort of 6-12 months, but our electricity demand as a country has been fairly stable and fairly flat for the last couple of decades, and only now we're starting to really pick up. And it's a good thing because we're picking up economic activity, we're picking up these data centers, we're picking up manufacturing, but it's also a big challenge that we have ahead of us. Now, it's what's that crystal ball, and how do you tell what that future holds? Is it 30 gigawatts of extra data center demand? Is it 60 gigawatts of extra data center demand? Is it even more than that? What's the overall demand growth? Is it going to be 50, 100, 200 gigawatts total? So the sort of band of uncertainty is quite wide in terms of what the future holds and what that demand growth is actually going to be. I think what the trillion-dollar question really is how you go about serving that demand. Whatever it is, it's going to be big. It's going to be very big. But how do you get to serving that demand? And there's a lot of different options on the table. I think every energy option out there is being looked at and is needed in solving this problem. But the timelines are quite varying. Nukes are probably 5 or 10 or more years out. New gas generation, you can't get a new gas generator for probably 4 or 6 years at the very shortest. And so the most immediate and economical solution is really those renewables and batteries. I think from a pure data center play, you brought that up. What are the specifics in terms of how we address the data center needs? There's a lot of variability there, and I think that goes back to speaking to the uncertainty in exactly how we're going to bring all of this online. There's everything from completely off-grid microgrids that are powering data centers until they can get grid connections, to working really closely with utilities to bring extra generation on board. And I think there's a lot of questions there, but there's a lot of smart people in the industry that are working really hard on those. So I've got a lot of confidence and a lot of faith.
Do you think we'll see a lot of batteries hosted at data centers?
Yes, I think we'll see a lot of batteries at data centers. I think we'll see a lot of batteries on the grid next to data centers. I think we'll see a lot of batteries that are on the grid far away from data centers. I think we're just going to see a lot of batteries everywhere on the grid. We've made immense strides, and we've figured out a whole lot of really interesting and really fascinating ways of using batteries. But I think that there's a whole bunch more that are to come, and I'm really excited for what's going to come.
So we've covered innovations in safety, system design, integration strategy. supply chain development. What other technical innovations in batteries are you most excited about right now?
I think, obviously there's a lot of technology advancement. I think there's some great battery chemistry plays coming out. And I think that as the markets shift to these longer and longer duration, some of these longer duration battery chemistry plays could be really interesting if they hit the right timing. I do think that the advancements that I'm most excited about are really how to get that deployment to be smooth, how to get that deployment to be effective, how to keep these systems really up 99% of the time, 99.5% of the time, just keeping that massive, really, really stable uptime and get the reliability that you need to support the grid. Fundamentally, though, I do think that we have a great technology in LFP and that we're starting to get really good at deploying these huge sites quickly and effectively, and that there's just a lot more value that we're going to get out of them as we learn to manage fleets that are at the tens or hundreds of gigawatt-hour scale or even thousands of gigawatt-hour scale. That's where a lot of the advancement is going to come. It's the scaling question and the scaling problem that we have ahead of us.
Do you still get the same thrills working on energy storage as you did working on IndyCars?
I'll be honest. Every time you turn on a 1 gigawatt-hour site, there's a little bit of a thrill. There's a little bit of excitement to see that happening. It is still fun for sure.
Tristan Doherty, thank you so much. I enjoyed this conversation.
Likewise, thank you for having me.
This episode was produced in partnership with LG Energy Solution Vertech. LG Energy Solution Vertech is the U.S. energy storage division of LG Energy Solution, here to be your lifetime energy storage partner. For more on the company's approach to safety, performance, and its commitment to the U.S. market, follow the link in the show notes.